This conference is brought to you by CallStack, your React and React Native development experts.
Hello, everyone. Before I begin, I want you to take a moment and reflect. Remind yourself why you're here today. If you're anything like me, you are here to meet people in person and also maybe learn something new. And learning something new is not always easy. Heck, sometimes it's outright uncomfortable, like the abrupt interruption of a sick fault 8 hours into your vibe coding session and you forgot what language you were even writing in. As you watch my talk, I want you to remember this is all just JavaScript. If you squint a bit, you've got this. And now I want you to imagine a future. It's a future where, if you're an app developer, almost all of your dependencies are compiled ahead of time, so your app is very fast and almost builds instantly. And you can reuse packages from the existing Node.js ecosystem, or at least it's no longer impossible to do that. At the same time, if you're a library author, you can use your favorite native language and build tooling when you're authoring your native modules. And there's no need to declare a pod spec or a Gradle project. And depending on your choice of language, you might even be able to write and maintain your binding and types for your native library. Basically have that automatically generated for you. You also get timely, as a library author, you also get timely feedback, so you get errors right away instead of waiting for somebody to upgrade Xcode and create an issue on your repo. And you also don't need to have a test app necessarily. In fact, you can test your native code without starting an emulator or a simulator. And this is not simply the future of React Native, it's the present. And these and more improvements in the developer experience is what gets me excited as I help bring Node API to React Native. So first, I want to clarify a few things. What the React Native community refers to as native modules. It's basically the same thing that the Node.js community refers to as native add-ons or C++ add-ons or simply add-ons. And I'll be using those two terms interchangeably. It is the same thing, native code callable from JavaScript. And another thing you might find confusing is the naming. You should know that the Node.js project renamed NAPI to Node API 4 years ago. So now Node API is the new term preferred by the Node.js project for new information about this. Let's start with taking a step back and ask ourselves, like, why would you ever need a native add-on in the first place? You reach for this if you want to interface between your native code and JavaScript, as I said. Either because you have some very computationally heavy problem that you want to compute, and you cannot reasonably do that in JavaScript, or because you have existing native code that you want to reuse across platforms. This could be like a database, for example. Perhaps JavaScript is not the only place where you want to have this native code running. And finally, you might need access to APIs not readily available through the built-in JavaScript APIs, like, for example, this injecting the CD tray, for example, or something else, maybe more specific to the platform. I would say the two first use cases is where Node API really shines at this point in time, and the last one is something we are working on improving. But this presentation is not about Node.js, it's about Node API. And you probably saw Vladimir and Kalev's talk yesterday on Node API. And if you're watching this recorded, I highly encourage you to go back and watch that first. Here's a quick recap, starting from what it's definitely not. It is not the Node.js runtime APIs. This is the stuff like the built-in modules like file system, path, nor the Node.js specific globals like the process global. This is not what we've built. Okay, stuff like that is not what I'm referring to when I say Node API. It's not the same thing, although much of the Node.js runtime APIs are built on top of Node API. Okay, but then what is Node API? It is an API to access JavaScript from native code, much like JSI, except it's declared through a couple of C header files. And this is important because it's an ABI-stable API, which means an add-on built today will also work with a future version of the runtime, or React Native in this case. And I'll get more into that later. It is very easy to download the headers. You just npm install them or go on GitHub, and you'll find a few files in there, and half of it has two parts. The first part is the engine-specific part. This is what is brought in by Hermes in our case, and then the other part extends this engine-specific part with runtime-specific capabilities. This would be Node.js-specific, and in our case, React Native-specific. So I'm starting with the engine-specific part. These are functions to read and create and manipulate JavaScript values. And an example of this is getting a global object, or creating an object, or setting a property, or getting a property value. This is the sort of thing you can do with this API. And the second part is the runtime-specific stuff. And these are less related to JavaScript as a language and more related to, in this case, Node.js or the runtime. It is an extension of the engine-specific part, so you can see here we do an include of the other things. And then it provides things like, for example, creating a buffer, which is not a part of the language specification, and stuff like scheduling and canceling asynchronous work on the event loop. I'll say this again because it's really important. The runtime part of Node API is not the same as what I referred to earlier as the Node.js runtime API. Okay? So while originally intended to abstract Node.js's internals, it sort of became the de facto standard which other engines and runtimes started implementing, and basically to support running existing Node.js add-ons in the ecosystem. And at some point, we also had this implemented in Bun and in Dino also. And generally speaking, you can implement Node API add-ons in any language with a C foreign function interface, CFFI. Trivially, that can be C. And you can basically, you can see here it's pretty verbose. It's error-prone because you're relying on status checking instead of exceptions, and manually checking your arguments when you try to access stuff. So here, for example, we are including the header, and we initialize the module. And in this case, we are creating a function referring to the sum with the big S. Here is the implementation of that function. And now we are setting a property called sum on our exports object. This is what is going to be returned as the thing is initialized. And this is the implementation of the sum function, where we have to get out the different argument values, convert them into the native representation, and we have the computation. And then we return the result, like creating a JavaScript value from the native double and then returning it. So you can see it's really verbose, and at least if you ask me, but it's doable. To simplify writing these add-ons, the community has built higher level abstractions on top of the C API. And one example of this is the Node.js project's own, it's called Node Add-on API, and it's a header-only C wrapper around the C API. So again, you import the header file, and now instead of the other headers, like we are importing the API-H file instead, or including it. And we can now use a more abstract construct when creating the function and setting the property. You can see it's shorter here, more idiomatic C++. And it's less verbose again to implement the thing, because the calls here into Node API is still through the underlying C API, but it's much more concise and idiomatic. Yeah. For example, you can see, instead of doing the check of the status as we call into Node API, we are relying on now C++ exceptions being thrown from the binding. Okay. My final example here, it leverages code generation. So it's taking one step further, and just like the C# demo that Vladimir demoed yesterday, this is now an example for a Rust binding. And you basically declare that you want to use the binding generator. In this case, NAPI RS is the binding generator underneath here. and you annotate your function bringing the actual implementation, and that's it. You could easily forget that you're actually implementing a function callable from JavaScript here. And this is powered by this project here, and it's a binding generator which also generates the TypeScript declarations from this piece of source code. And this is opposed to the React Native CodeGen or Nitro modules, where you annotate your types, and then you generate a code that you need to implement. This is the other way around. You're generating the types from the native code. It also powers many other projects, many of the recent JavaScript in Rust projects, such as the JavaScript oxidation compiler, OXC, which in turn powers roll down and roll up, RSpec, Parcel, a lot of other popular libraries. And this is also used in tools like Cursor and Tailwind CSS, and also Vasel's Turbo Repo and NX. So what I'm trying to say is, if you're using this tool, you're in good company, and it's not going anywhere. Cool. And what was it I was talking about? Yeah, okay, I wanted to talk about bringing this to React Native, right? And I can feel the question on everybody's mind right now. If React Native supports Node API, can I just npm install any package intended for Node.js? What do you think? The answer is nope, you cannot. And why is that? Packages intended for Node.js, they have their native add-ons provided either as source code that is built on the developer's machine, or machine code known as a prebuilt binary. In some cases, they ship both. For an example, for an existing package to be usable in a React Native app, we need any of these add-ons included to either have a prebuilt for React Native or ship with their source code included. Even with the add-on built, the native part of it, the package might also contain JavaScript code that is dependent on the Node.js runtime APIs. And if you take anything away from my talk here, that's not what we built. Potentially that can come in the future, who knows, but that's not the intent of the project. And writing and maintaining a piece of native code is often the hardest part, so I do see possibilities of maybe lifting out or forking existing Node add-on packages when the license permits it. But this is still an area of ongoing exploration as we build tooling around it and help make that much more possible. If you have any ideas on basically Node.js add-ons that you want to see brought to React Native, I really want to hear about that. Cool. This slide is not about Node.js, and the talk is not about Node.js. You're at a React conference, right? This is about bringing this to React Native, and you probably also want to see this working in React Native now. And instead of doing a live demo, I did some recordings. And here I'm building a Node API add-on with the sum function written in Rust. And looking at the code, you can see that I introduced a bug here. We say a minus b instead of a plus. And when we build this, you can see it's emitting a require function, a call to require with a .node extension on the thing that is requiring. And you can also see that I'm importing the package here using the sum function directly into my code here. And let's see, yeah, this was the bug that I introduced, and you can see it is buggy. Okay, let's try to fix that. Now, I want to show the developer experience of fixing that. So I change the code and I run in this case, the Ferric build tool. It's wrapping the Node API, NAPI IRS project underneath. Let's just do that again. Fixing the thing, time traveling here. Running the thing, and you can see it's building the simulator. And then now I'm linking it, almost like auto linking, but like you can do that manually, or you can have your build tool drive that. I'm just showing it manually here. Now I try to rebuild the app. And it will take just a few moments. Drum roll, please. Do you think it's gonna work? So this is not using the new prebuilt for iOS, right? So that's why it's not as fast. But yeah, it worked. Yay. Cool. Thank you. So this is the slide where I show the awesome logo of the project, and come see me for stickers if you're interested. I'm also going to leave this QR code just for a few seconds. It's for the repo on GitHub in case somebody wants to scan it or star the repository maybe. I was seriously considering making this a Rickroll, but also decided not to. It would be too disturbing. Okay. This is what we've built. Vladimir and the team at Microsoft built the Node API support into Hermes, and we built a package hosting Node API add-ons in the context of React Native, helping them link at build time and load at runtime. And we have built some build tools for compiling and assembling the add-ons into directories of multi-platform prebuilds for React Native. And we've built testing infrastructure to help reuse tests from the Node.js project to gain a confidence into the implementation. And finally, examples of usage of what we've built. So starting with the host package here. At the center of everything, we have the host package. It's called React Native Node API. And it's called the host package because it hosts the add-ons into your app. Currently, it downloads a special version of Hermes with Node API support. I'm going to get into that later. And it implements a turbo module with basically the second part of the Node API that I presented in the beginning. That was the engine-specific part and the runtime-specific part. This brings the runtime-specific part. It also has a require node add-on function that you call to load and initialize add-ons. And it also comes with a thing called the weak Node API prebuild that you use when you build your add-ons. You link against this thing. And I'm going to get into the reason for that very shortly. It automatically discovers and links these add-ons to match, or these add-ons that match the specification that we have published. And finally, the host package exports a Babel plugin that you can use to transform require calls of these .node files into calls for the require node add-on function. This is like one of the steps that we try to take to make it easier to consume existing packages made for Node.js. Okay. When you want to publish a package with a Node API add-on intended for React Native, there's a few requirements. Your package needs to declare a dependency or a peer dependency on the host, and it either ships with the source code or and invokes the build tools on install, or more likely ships with the prebuilds already built, targeting the individual React Native platforms that it supports. And this is what we recommend at the current time. It has no, your package cannot have any dependencies on the Node.js runtime APIs, or it needs to be, if it has, it needs to be isolated, like the code that's intended for Node.js. I did a talk at WebDevCon in March about building universal TypeScript libraries, so you could watch that if you're interested in knowing about more about how to do that. And you can leverage basically other Node API compatible runtimes like Node or Dino or Bun when you want to exercise and test your native module, which is a super good advantage. So I mentioned prebuilds earlier, and this is the idea about shipping native code with your package archive, built ahead of time instead of shipping just source code. And this technique is increasingly being adopted by React Native, most recently to ship React Native CORS dependencies as a prebuild for iOS as an opt-in feature in 0.81. And this was also mentioned yesterday. When I want to talk just a bit more about like what that requires. So when two pieces of software interact, we know that we call this an API, right? Exposed by one part to the other. And a stable API means that I can write software today that I can use together with the other thing on a source code level. In the context of machine code, we need a bit of stronger guarantee for these two pieces to interact, such as instruction sets, memory layouts, and call conventions. That was also mentioned yesterday. But a stable API basically means that I can pre-build a Node add-on today, and then I can use it in future versions of React Native. The benefit of not having to compile all your dependencies gives you, the app developer, a faster build time, and the author of a library gets much more timely feedback instead of relying on people creating issues on GitHub when they upgrade their Xcode version and everything is broken. They can choose, the library author can choose their own build chain, their own tools when they build their library, which is also awesome. You can use CMake for building your, driving your iOS project, for example. Yeah, and did I mention that Node API is ABI-stable, which is awesome. Now, with all that context out of the way, we get started onto like what it actually takes to build a Node API pre-built for React Native. We have the specification on the docs, like speaking out like what the final result needs to look like. And for technical reasons, while it is technically possible to basically ship a Node API add-on in your source code, traditionally Node API add-ons were distributed as dynamic libraries, and this is also what we want to support. So there are some platform-specific requirements that applies when you do this, and we've tried to document here on the, as I said, on the repo. So for non-macOS Apple platforms, dynamic libraries, they must be packaged in an XE framework of framework bundles containing dynamic libraries. I have no idea why that is, but that's what the doc says. And this is what it looks like on a file system. Yeah. On Android, on the other hand, dynamic libraries, they have a slightly different thing where at runtime, when the linker loads in the dynamic library, the dynamic library cannot access any symbols, not even the global symbols, from anything that it doesn't explicitly declare as needed. So, yeah, and this is, so that's another requirement that we need to take care of, and this is what it looks like, the pre-built format. It's like a JNI-like, JNI libs-like directory of multiple architectures. Okay. So I mentioned earlier that Node API has two parts, the engine-specific part implemented by Hermes, and then the runtime-specific part brought in by our host. And we want to contain the API surface a bit, so we don't expose all of Hermes or have to ask all the add-ons to link against Hermes. So this is why we basically introduced a dynamic library that we call the weak Node API library, which it's going to have the Node API functions presented to the add-on, but it won't have the implementation itself. That's going to be injected by the host package. And when inspecting a pre-build for Android, for example, you can see here that it's listing the weak Node API as needed, because that makes it possible for it to access the symbols. And when doing the same for pre-build on iOS, you can see it's the same thing, but now it's within a framework bundle. And you can see here there's no direct dependency on Hermes, no direct dependency on React Native. So now that you have your app with all these Node API add-ons laying around, you want to somehow get that into your app bundle. Like on Node.js, you have the convenience of a file system that you can, at runtime, you can traverse the file system and just pull in the thing, but you need to get it into an app bundle to get it onto a device, right? And we made it in a way where we have build tooling that your own apps, build tools like CocoaPods, Xcode, Gradle, Android Studio, they can call into to scan for files and copy them into the app bundle. And while it's doing that, it's also being careful of like renaming to avoid naming conflicts. So if two packages ship Node API with the same thing, the same name. This is what it looks like, by the way, to manually link 15 Node API add-ons into an iOS app. Loading the add-on, you could either do the require call that I showed earlier, or you can use a lower level API like this, the require node add-on, where you specify the package name and the path within the package name for the add-on. It's pretty simple. Yeah. That's it. The object returned will be the exports object initialized by the module. And we provide tools for, that's the next thing about the project is that we provide some new tools. For example, we provide CMake RN. This is the equivalent of another tool called CMake.js for the Node.js ecosystem. We have the same thing here. Basically wraps CMake to help you build Node API add-ons for React Native with C and C++. And the next thing is JIP to CMake. As we were taking in the Node.js tests, they used the JIP build system. Vladimir also showed that yesterday. And this tool here can help you transform a JIP configuration to a CMake configuration. Because we didn't want to do an integration with JIP directly, we wanted to just use CMake, for now at least. Maybe that will change in the future. And then Ferric is the thing that I used, where it's basically to use, you can use this to build React Native Node API add-ons with Rust, and it wraps this Node API RS project to build TypeScript declarations and the bindings, generate the bindings. And also, this tool and the CMake RN takes care of basically, the biggest part is like taking all these dynamic libraries and constructing these multi-architecture platform directories that is needed to load into a React Native app. If you're interested in learning more about this, like the Ferric tool, I also gave a talk at React Summit about Rusty native modules for React Native, talking about the tool. Okay, so before we all get too excited, I can feel the excitement in the room right now. I want to also be honest and mention some of the limitations. Only a few of the runtime specific like parts of the Node API spec is missing, but there are some still in progress. And the Hermes support for Node API is still an open PR, which is being actively worked on. But this is why we need to compile Hermes from source, because we are using a fork of Hermes to do this. And this is something that I expect to go away. This is why the initial app build is slower than it could be, and also that it has specific requirements right now on specific React Native versions, because I need to take the version of Hermes and reapply the patch adding Node API and publish that. So it's like, it takes some time for me to catch up on that. Okay, and what does the future bring? Looking into a crystal ball here, I guess I mentioned like getting the PR merged is super awesome, and if you see Vladimir around in the conference, just give him some cheering and some good luck with that. I think he's been working on this for a long time. It's a massive endeavor. I know that he's been very rigorous around getting the testing and the confidence in the implementation, even though this implementation has already shipped and ran in React Native for Windows for a long time. But this would be really good when it lands. Also, other future plans. So we intend to implement these missing runtime functions, the things that are left, and build something awesome with this. I think we could use this to build more web spec compliant APIs. I think that would be really cool. I know that Jamie Birch and the NativeScript team wants to bring their binding into the React Native ecosystem. Personally, I'm most excited about other like Rust libraries, like the AutoMerge library, which is a Rust-based library. I want to get that into React Native, and I can see how I can use a tool like Ferric to do that. And all of these things, building something awesome, could inform the developer experience improvements that we can do. And we expect to bring support for other platforms, out of tree platforms, and potentially we could also use tools like this EM API to bring support for web through basically an implementation of the Node add-on functions on like through WebAssembly and in a browser. Yeah. And also just in general, just simplify the experience of building, using the tools that we have to also drive a build of Node.js prebuilds directly. So you don't have to invoke two tools, one for React Native and one for Node.js. You can just invoke one. That would be awesome as well. And finally, we see opportunities in like decoupling some of the Node.js tests from the Node.js runtime APIs, so we can increase and make it simpler for us to test and exercise our implementation. Okay, so I mentioned initially that I go to conferences to meet people, and I want to meet you as well. And sometimes it's not easy to figure out a starting point for a conversation, so I prepared a few questions for you guys. Does the prebuild spec make sense to you? Like if you look at the specification online, I want to get some feedback on that. And what platform should we target next? And also, what would you build with this? That would be awesome to know. Good. So before I end, I want to acknowledge that how much fun it's been to do. Here's just a few faces and names of the people that was involved in the thing. We've been meeting almost weekly since January online to just talk about this, and you can join the Discord as well. It's the CallStack Discord. We have a channel there. And yeah, without any of these people contributing their valuable time and code and documentation and also just valuable perspective, none of this would have been possible. This is a nice picture from this conference of some of the people involved. So that's all. Thank you so much for your time and attention. It's a rare commodity these days. So if you're a library author and I want to see you try this out, it's a great place to start if you try the example linked from Jamie's article on the CallStack blog. And if you're an app developer, you can find existing Node add-ons that you want to try and use, and you can try to use the build tools on them. If you're an open source enthusiast, I think you should join the Discord and find issues that you're interested in on the GitHub, and spread the word. Thank you so much. That's it.